As mentioned, we will be discussing two main use cases within Allianz BeNeLux for graph analytics. The first one will be around customer and customer profiling, and the second use case will be around fraud detection. As mentioned, Sudaman unfortunately couldn't make it today, so it's the two of us who will be sharing our experiences. Just to set the stage, I'm not sure if everyone is familiar with Allianz as an insurer, as an insurance brand. Globally, we're one of the largest players and quite well known. I think in the Netherlands, we're mainly known for our small and medium companies and for the large clients. In retail business to private individuals, I think we are less known, but it's becoming more and more given the Allianz Direct brand launch this year. As part of Allianz Group, the both of us are working for Allianz BeNeLux. So we're located in Rotterdam, in Brussels, and in Luxembourg. And actually, we have a focus team which is called the Data Office, which focuses on actually centralizing all the data knowledge and the application of new algorithms in a traditional business like insurers, where, of course, a lot of processes are already developed and are still in a traditional stage. And what the data office here is trying to do is actually assist and develop new algorithms, of which graph analytics, of course, is one.
Yeah, so the journey of the data office BeNeLux started in 2018, guided by Sudaman. And the first thing he did was integrating the different silos into one golden record. So cleaning the data, deduplicating the data, and enriching it with external data. Once this was done, we could load all the data in a golden profile and combine it with across different domains. So combining customer data, broker data, product data, and even with some external data. Then, once we have the golden profile, we could load in the graph, we could apply analytics on top of it. And this year, to 2020, we see several of our use cases on Neo4j are having more and more customers, and those are the use cases we want to highlight to you. So let's start with the first one, the customer care center. The data of the customer is loaded in a graph and then visually presented to the customer care center agent. It's literally putting the customer in the center, and it gives the customer care center agent a 360 view of the customer. For example, Gabriel, you can see his family relationships, you can see the products he owns, his driver statistics, and even what he likes and what he doesn't like. This is available for the customer care agent. He can quickly search on it and act on it. And the goal is to have really help the client quickly and as efficient as possible. Let's look at an example how it's used.
Learn how we at Allianz unlocked true customer centricity in this new digital age. Meet Gabriel, loving husband and father of two. Together with his wife, they own a house and a nice yellow car. Gabriel has protected his family with several different insurance contracts. These contracts were subscribed via different brokers, and Gabriel's information is spread across various lines of business. Meet Jennifer from Customer Contact Center. When Gabriel calls, she needs to dive into different systems to get Gabriel's full picture in order to offer him valuable services. To provide Jennifer with that 360-degree view, we have built a solution that integrates all this scattered information into a single customer golden record, enriched with external and derived information. On top of this 360-degree view of Gabriel, we also leverage graph analytics to deliver insights on his life situation and connections, previously hidden within the data. The result is a customer golden profile that allows Jennifer to offer Gabriel the best service possible. With our new solution, Jennifer can search for Gabriel's 360-degree golden profile using any piece of information. Next to free text search, a recommender engine also assists Jennifer in offering Gabriel personal advice and relevant recommendations. With these recommendations, Jennifer can deliver a true customer-centric experience to Gabriel by proactively answering all his needs. Thanks to this, Gabriel can feel protected and secured in his future with Allianz.
As already mentioned in the video, with all the customer data in the graph, we added extra relationships that were previously hidden in the data. We added them explicitly in the graph. For example, adding the best next action for the customer, so the customer care agent or the marketing department could recommend relevant products to existing customers. And then the third example is the fraud underwriting.
Yeah, so as mentioned, a small talk about the topic of fraud, which is my main focus. The graph is currently being applied in the context of claims fraud. So this is customers submitting fraudulent claims, in this example in motor insurance, so motor retail, where actually we're simply using the visual aspect of a graph. So aggregating and combining multiple different data sets. As mentioned in the morning, traditionally you would use SQL, perform joins, and get all the data together. What we've tried to do here is actually create a visual overview of the network of people and of entities that are involved in a claim, and actually presenting this to the people in the claims fraud department. So traditionally, on one hand, you have the IT systems, pretty outdated, filling in a claims number, getting all the details, finding the name of a customer, and then having to remember, I've seen this name before, entering it again in the system and finding that he is involved in another claim. So in this way, we actually combine it into a visual overview where we're able to not only look on name for a certain party, but actually look at him from different roles. Because if you're vaguely familiar with insurance and with claiming a damage on your car, you can actually have people involved as in multiple roles. So usually you can either be a policyholder, you can be the driver in a claim, don't have to be the same people. You can be the counterparty in a claim, and as soon as a claim gets big, this actually blows up the amount of people that are involved. And you can also be involved as a witness in a claim. And from a traditional perspective, these roles are all separated. So in a SQL database, you would have a column with insured person, driver, witness, and it's very complicated to, first of all, find these people, and second of all, to actually link them and to see links between them throughout different claims. And the example that we brought here, it's quite readable. The first example, I would like to give is the back button, yeah. Is actually related to fraud rings. So what we do here is we extrapolate known fraud patterns, so people involved in multiple ways with each other in different claims, and actually we apply these as graph queries on top of our database. So what we see in this example is we have one person who is driving and involved in two different claims, so he drives and is involved in a claim, and in this claim he is actually involved with another car, so that's the counterparty, driven by a guy living at an address. In the other claim, however, we see that actually he is involved with a different person, but these two are living in the same address. This for us can already be a warning if there's multiple claims in a short time period with not the same person, but two different people living in the same address, that something can be up. Another example for which we currently are using it and with which we are extending the traditional graph that we have so far is actually extending this data with new rules and new triggers to automate alerts for us. So on top of having the ring and seeing the visual relation between the entities involved, we can also add, in this case, warning lights. For instance, if a vehicle is either listed as stolen in a database, whether the car has been imported or not, close to a claim date, which is a very vital piece of information, and whether the car has had its periodic check or whether it was up. So for the Dutch natives here here present, the APK. If either the APK, so the periodic check, has expired recently and the car is then involved in a claim, that's very suspicious. But we can also have older cars, say 15 years plus, which are supposed to have their periodic check done, but then have a crash just a few days prior to the date that the check was supposed to be done. This can also be an indicator of a car which would not have passed these checks. So the customer knew that this car would have been worthless, in essence, and actually then they would stage a claim and claim the final value of the car. So in this way we can actually, wrong button again, we can actually assist the team which is currently looking at this in a traditional way, and we can aggregate all the different sources that they use at this moment. So we can, in this graph, we can include not only our internal data, but also enrich it with external data, which is either publicly available, which we have available internally from the fraud registrations, or which is available in the central Dutch fraud registration. And all of it can now be combined in a visual view for them to just instantly see that something is up, yes or no. Of course, this result is not conclusive, so it could still be that something else is up, which is not yet included in here, so there's an actual relation between people which is not known from the data at least. There's a relation which is not captured. Still, they would need to continue, but a lot of these scenarios that we currently have are actually covered by looking at the graph and instantly seeing a visual confirmation or not of certain scenarios. Some obstacles that we have seen. Of course, I think in the morning we heard a lot of talk from the Neo4j side about the capabilities that Neo4j brings and the advantages that a graph database brings. But especially in a traditional company, there are quite some challenges and some obstacles to implementing the graph. The first one from my perspective would be the transfer from relational databases into graph databases. For a problem that's already there, usually the line of thinking for analysts, for data scientists, for all the people involved, involves a SQL state of mind. So there's a lot of thinking in terms of joins, in terms of combining data sets. And the challenge to go from relational to graph is actually a very big one and a very important one. So the step to decide how your graph model will look like and what the relation is between entities is a very relevant one and a very important one. And what we have seen so far is that this actually takes quite some iterations to get over with. So the initial graph model that we once chose, that we once deployed, is no longer the one that's being used today because it actually didn't fit the graph line of thinking. It was thinking from a SQL perspective and just directly applying that on graph, which turned out to be not the right decision. So it's continuously evolving, and it's really a new line of thinking to follow. The second case, the second obstacle, which doesn't have to be an obstacle, of course, is getting the business case approved. So getting the return on investment for a new technology like Neo4j, deciding to use it, and of course seeing the value. I think a lot of you here this morning have seen a lot of nice examples and think, okay, this is the perfect example for my company, for my department. But then the question usually becomes, how can you generate a business case? What is the value that will be provided when we take on this tool? What's the value of a visualization? And this actually can be quite a challenge if you look at it really from a traditional perspective. We invest some X in getting Neo4j, getting the developers, getting the tooling, getting the cloud infrastructure if required. What are the gains that we get? And the way that we have had to solve this so far is really starting small and thinking big, something that I'll skip on in the last slide, but already thinking, where can we get this? So make a really small start, take, in our case, one line of business, so one insurance product, think of one use case to do, for instance, fraud or customer profiling. Start from this small thing. Be sure that you can scale it up, so be sure that it is easily extended with an infinite amount of new features, an infinite amount of processing power, but be sure that you can deliver something small which can already show this value. For fraud, the way that we had to do this is also starting in one line of business, actually skip over the entire visualization part and just build something very quickly. So no licensing involved, just quick and dirty, try to see if it works, if we can convince people of the value, and if the answer then turns out to be yes, scale it up in full and actually set it up. The final one, governing the flexibility. As Sophie showed, we've been playing around with the graph and with Neo4j for around 2 years now. And of course, the process is always slower than you would expect. And by now, actually, we have many spin-offs of graph. So before we thought we just build one big graph and include everything in. That will be the central, the master graph, let's call it that. But then on the side, actually, you find out that there's a lot more side projects which require either their own graph model or their own specific nodes to add, which you don't want in another initiative because it will just pollute your view, it will pollute your database. And here we've actually seen the challenge to govern this flexibility. So to see, do we actually need one master graph which has to be audited by someone centrally? Or do we want to keep them separated and get the insights from either and keep them apart, which actually shouldn't be the goal of a graph, of course. You want all the data in one central place and then just query whenever necessary. As mentioned, keys to success. I think the main one for us as a data office from what we've seen so far is the top one. So really thinking big, but starting small. So be sure that wherever you apply this graph, you can show something very small to start, do a quick iteration, and then be sure that once you deliver that, you can actually convince all the stakeholders that this is the way forward and that this can prove value not only to one department, but actually by sharing data across departments that it can prove value to anyone because it just allows data to be centrally available. If you work with existing departments who have their own way of working, be sure that whatever is developed actually makes sense to them and proves value to them. So in this sense, don't assume that you know what they want, but actually get this engagement going with the stakeholders and check with them what they need and especially what they don't need in terms of data. And especially with graph, I think this is an important point to note because for traditional people, non-data natives, I would say, they never know what the options are, what we can actually do with a technique like graph. So we really need to tell them what the possibilities are before they will see what actually, whether it makes sense to them. They can't think of something else than a traditional way of working, and they need help there to explain this. And another one really working in our case from business initiative. So find a use case, find a line of business where it actually makes sense to do this graph demo, and then work from that.